Hi everyone, this is Jeff Morrow coming to talk to you about new features in HDExaminer. But first, an announcement. Earlier this year, HDExaminer was acquired by Trajan Automation. Same product, new company, and we have big plans for the future. I'd also like to include a quick apology about the fact that there was no YouTube video about new features in version 3.3. That was simply an oversight on my part, one that I'm correcting now. The first new feature I want to talk about is that starting with version 3.3, HDExaminer can now read Bruker timsTOF data. So I have an example up here. It's got the sort of narrow peaks and high resolution you'd expect from Bruker data, but there's also this ion mobility switch that indicates that it's reading ion mobility. So timsTOF is Bruker's entry into the IMS market, and now HDExaminer can read that data. The next feature to talk about is that starting with version 3.3, you can import mass spec stick data rather than profile data into HDExaminer. So you can import centroided data rather than it requiring profile data. Now, I've brought in some stick data here, and you'll notice that it actually looks still like profile data when you browse it in HDExaminer. Well, that's because the way that it deals with stick data is that it puts Gaussians over them to turn it into profile data. That made it so that all the existing algorithms in HDExaminer would work the same way. We still recommend that you acquire your mass spec data in profile mode, but if you have stick data, HDExaminer can now read it. Also new in version 3.3 is the calculation progress bar. So I'm going to recalculate this project and show you what I mean. Before, HDExaminer would simply have a rolling non-progress bar down here in the bottom right to show you that it was calculating. Well, now it will actually figure out how much of the calculation it's finished so far and show you an actual progress bar as it does its calculations. Next up in version 3.3 is the fact that now in the protein view, you can right-click on a peptide and set its confidence level right here. So if I set this one to low confidence and then recalculate the heat map, you'll see it disappears because this view doesn't show low confidence peptides. This is exactly the same functionality as if you did the same thing in the peptides view. So for example, if you right-click on a peptide, you can set it to low confidence. This is the exact same thing, except it's in the protein view instead of the peptides view. The last feature I want to talk about for version 3.3 is the fact that the statistics here when you click on a peptide pool are now given on a per protein basis rather than overall. You may know that a few versions ago, we introduced the possibility to add multiple protein sequences to a single HDExaminer project. But these statistics, when you clicked on a peptide pool, were still based on the combined multiple protein sequence. So now that's different. Now you can actually get statistics for each protein separately. So this is a 2-protein project, and you can see coverage statistics and such for both of the 2 proteins. And if you scroll down, you can actually get the overall statistics as well, which is what previous versions of HDExaminer used to give. Moving on now to version 3.4, the first new feature is that HDExaminer will now warn you if you open a project file and it cannot find the MS data files or cannot read those files. So I will open such a project now and show you that when it has a project that it can't read the files for, it will show you this warning. One or more MS data files could not be found. It will also, here in the analysis view, put one of these warning icons next to any mass spec data file that it couldn't find or couldn't read. This is usually the result of moving a project around and the files being in a different location relative to the project than it expects. To fix that, you can actually use a feature that's been around in HDExaminer for a long time. If you go to Tools, Options, here under Data File Search Paths, you can actually give HDExaminer a list of directories that it should look for MS data files if it can't find them. The next new feature in version 3.4 is the Chiclet Plot. If you're here in the peptides view and you click on a peptide pool, now in addition to the butterfly, residual, volcano, and woods plot, you also have the option of the Chiclet Plot. This is the plot that appears in some literature in HDX, where the x-axis is the peptide number and the y-axis is the deuteration time, and each of those points represents a little chiclet, as it's called, a rectangle that is colored from blue for minus 100% change to red for plus 100% change. This is intended to be a comparison view, but you can also look at a single protein state, or by picking two, you will see the difference between those two states. In addition, mousing over any of these tells you the peptide that you're looking at and the time point. And if you click on one of them, it will take you to that peptide in the peptides view. And also, the Chiclet Plot uses the same color key as the heat map. So you can adjust this by going into the heat map settings and changing those colors. Next up, in version 3.4, we've added support for blank runs. What does that mean? If you do blank LCMS runs in between your deuterated runs to check for signal, you can now import those blank runs into HDExaminer. HDExaminer will look for your peptides in those blank runs, except of course, if it finds them, it flags them as bad rather than flagging them as good, because if you have actual peptides in your blank run, chances are you have carryover that could impact your results. So how do you add one of these blank runs? Well, here in the analysis view, if you add an experiment under deuteration, now instead of undeuterated, partially deuterated, or fully deuterated, there is also this blank option. And this option exists in the drag and drop import as well. The software will treat a blank data file as though it were a deuterated file and look for the results. If the software finds your peptides in those blanks, that's bad. And how it warns you of that is the next feature I'm going to talk about. The final new feature in version 3.4 is something we think is going to be really useful to all of you: peptide warnings. What are those? Well, anytime one or more of your peptides has something wrong with it, and we'll get to what that could be in a minute, something wrong with it, it will pop up one of these little warning icons next to it. And if you click on it, it will also show you exactly what's going on. So for example, this peptide here has a missing replicate. In addition, if you click on the warning itself, it will take you to exactly the protein state and the charge state where there's a replicate missing. And if we scroll down, we see, yep, here's one that's in red, there's more. And so this protein state for this peptide is incomplete. Now, the missing replicate is, of course, one of many different configurable warnings you can set. So if you go to Tools Options and look under Peptide Warnings, this new one right here, there's a ton of different stuff that it will warn you about, and you can turn any of these warnings on or off, and you can even turn warnings on and off globally, depending on whether you want to see them or you want to not see them. So what are all of these warnings? Well, peptide missing from a non-deuterated experiment, it means that it just couldn't find that peptide in an undeuterated, in one or more of your undeuterated experiments. Same with the fully deuterated experiments. If it couldn't find the peptide, it will flag it. Missing time points. If your peptide wasn't found at all in one of your time points, it'll flag it there. Missing replicates, you just saw. It's missing one or more replicates. Unlikely uptake plot. This means that the shape of the uptake curve for that peptide doesn't make any sense. Like it's jaggy or it goes down in weird ways. This warning shows up if your uptake plot doesn't look like an uptake plot. Unlikely bimodal behavior, that simply means that your peptide looks like it might be bimodal, but it's doing something really weird. So, for example, going from bimodal at one time point to unimodal at the next time point to bimodal again at the next time point. So stuff like that. If the bimodal behavior doesn't make any sense, this warning will show up. Negative measure D is if your deuterated result looks like it has a negative deuteration value. Measured %D exceeds some percentage of max. This is the opposite. It means that your measured deuterium for that peptide is impossibly high, where impossibly high is based on a threshold that you set here in the software. Measurements differ at a time point by more than some percentage of max D. Well, what that means is at a single time point, if your replicate measurements are widely spread by, again, an amount that you define here, then it will flag that as a warning. Let's see. The next one is measured back exchange in the full D experiment exceeds some percentage that you specify of max D. Meaning, if your full D experiment tells you that your back exchange is a full 60%, then you can tell the software to flag you if it's something really high. The non-deuterated cluster average intensities differ by a factor of 3 or more. So what this means, and again, it's a user settable threshold, it means that the absolute mass spec intensity of your different non-deuterated replicates are different from each other, significantly different from each other. Next up is the same thing, but for deuterated clusters. If the deuterated time points for a certain peptide have a wide variation in their mass spec intensity, this can flag that. Next up is peptide found in blank run. Well, this is what I talked about in the previous feature. The blank runs, you can turn on this peptide warning, and if it finds that peptide in a blank, it will give you a warning about it. So what it does, in this case, when it's set to 10%, it will find the lowest intensity cluster in a real deuterated run. And if the blank exceeds 10% of that maximum intensity, it will call it a problem and flag it as a warning. Peptide found with a raw single scan intensity. So this again looks at the raw MS intensity of your cluster, and you can simply set an absolute threshold. Some mass spectrometers have a threshold above which you're going to start getting saturation and therefore weirdly shaped isotope clusters. This allows you to look for that and flag it if it comes up. And then finally, you can set a warning if a peptide's mass is within some number of Daltons of some other peptide in your peptide pool. What this is useful for is if you happen to have two peptides in your project that are really close in molecular weight, you could mistake them for each other. And so this warning lets you flag that before it becomes a problem. So that covers all the features for HDExaminer 3.3 and 3.4. If you'd like to get in touch to ask questions about the software or potentially to buy the software or to upgrade if you already own it, please contact us at HDExaminer@TrajanSciMed.com. Thanks for watching.